This is 3 Steps to Sketch for Function Transformations. And today we're going to look at an example where we transform the identity function. So we want to graph y equals 2 parentheses x plus 1. And we'll use the on the graph method. Now, of course, note there are so many ways that you could graph this pretty simple equation. We are going to look at it specifically from the transformations lens. So how is this a transformation of the parent graph y equals x? All right, so let's get started. Here's our reminder of what we're graphing and how. And here is our 3 steps to sketch outline and a grid. All right, so it's worth noting that our parent function is y equals x. Let's just write ourselves a little reminder up here. The parent function is y equals x. All right, and our first step is to analyze our transformations. So we know horizontal transformations affect the x coordinate. They're usually found in parentheses with the x. And so right here we see that we have one horizontal transformation. And when you have horizontal transformations, you want to think about solving order. Okay, so if you were to have an equation like x plus 1 equals 0, what would you do to solve this? You would subtract 1. So when we apply our transformation, we know that we will be moving left 1 or subtracting 1 from our x's. So let's make a note of that. Left 1 or x minus 1. All right, so that's our only horizontal transformation. And now we can move to our vertical transformation, which is this 2 out front. Okay, it's the only one. And we know that these affect the y coordinates. If there were multiple, we could use PEMDAS order. And what you see is really what you do. So if you see 2 times, we need to take our y's and multiply them by 2. So that stretches out by a factor of 2, or just multiplies 2 times y. All right, so now we have our analysis. We'll move on to step 2. We want to plot our parent function points and then transform them. Okay, so we know just lightly, and I'll do this in green, our parent function is this. Okay, we'll use 3 points. And now we can just move this graph according to the transformations that we recorded in step 1. So let's use different colors. That tends to help. Let's first start out by moving each of these green points to the left one. And I'll just mark X's in blue. Okay, so this is our intermediate graph. And we'll work from here to apply any future transformations. All right, so check off, we've done the left one. And now let's change colors to apply our vertical transformation. All right, so let's do this in red. We're going to stretch vertically by a factor of 2. So that's really just taking the y values and multiplying them by 2, or doubling your distance from the x-axis is another great way to think about it, a kind of visual way to think about it. All right, so our first point, our blue point at -2, -1, if we multiply that y times 2, it's going to end up at -2. And notice that the x coordinate stays the same. This transformation is only impacting the y coordinate. All right, the second blue x, well, that's on the x-axis, so multiplying it by 2 does not affect it at all. It stays in its place. And our third and final point, if we think about it, doubling the distance away from the x-axis, you can do that, or just multiply the y times 2. All right. And so that takes care of all of our transformations. So we actually can darken these red points. They're our final points, and we can sketch our graph. All right. So again, you can use any other method to graph this line. Some are more straightforward, but this is a great way to make sure that you really understand how transformations can affect a parent function.